The Nardelli-Hawking Renormalization Framework. From Google, January 11, 2026. The Nardelli-Hawking Renormalization Framework, proposed by physicist Michel Nardelli, is a novel, unifying approach in theoretical physics that connects quantum gravity, black hole thermodynamics, and information theory, treating Mach theta functions and string theory concepts as fundamental to space-time structure, particularly focusing on closed time-like curves (CTCs) and the golden ratio phi as attractors for black hole evaporation and quantum phenomena. T reinterprets discrete energy levels in quantum geometry as coefficients in these series, linking them to cosmic acceleration and holographic principles, with key elements including the Nardelli-Gemma golden constant, phi Pettis Majuscula G Majuscula N, and renormalization-free gravity concepts. The original equation is: simplify the equation assuming constants for convergence analysis. Assume the integrals are constants tuned for golden convergence, as in RTE, where constants like 1729 and 4096 are chosen to balance at phi. We introduce the following geometric integrals, which are assumed to be constant in the regime under consideration. The equation becomes: raise both sides to 7th power.
Assume maiuscola C pedice maiuscola quinto uguale a un for simplicity, normalized volume. Divide both sides by phi pedice maiuscola G maiuscola N alla settimo, assuming phi pedice maiuscola G maiuscola N diverso da zero.
This is a self-consistent equation. The constants are tuned so that at phi Pettis Majuscula G Majuscula and uguale a phi quasi uguale a 1.618665, it holds exactly. Golden scaling assumptions and numerical check. We analyze the scaling behavior of the 7th root operator under golden ratio tuning. The oscillatory factor is assumed to satisfy corresponding to a time parameter tuned toward a golden angle, like configuration, while the exact golden angle is given by 2 pi Greco fratto phi quasi uguale a 3.88, the numerical value.
2 pi greco fratto 13 quasi uguale a 0.483.
Is closer to phi alla, meno 2 termina apis quasi uguale a 0.382. This discrepancy is interpreted as a controlled adjustment within the golden scaling regime. For a unit spatial displacement divide Majuscula delta x divide uguale 1, the exponential damping term is approximated by
E alla meno divide maiuscola delta x divide fratto phi pedice maiuscola G maiuscola N, termina apice quasi uguale a phi alla, meno 1 termina apice.
Capturing the leading order golden attenuation of non-local contributions. Scaling of the energy, geometric sector. Under the above assumptions, the energy-dependent contribution scales as
Phi alla, meno aperta tonda 14.7 fratto 3 chiusa tonda termina apice uguale a phi alla, meno 32.666 3 puntini termina apice.
And is therefore strongly suppressed. This suppression is counterbalanced by the geometric, holographic term, which scales as operator tilde phi alla 49 for large phi Pettis Majuscula G Majuscula N. At the golden fixed point phi Pettis Majuscula G Majuscula N uguale a phi, however, the denominator can be normalized through appropriate parameter tuning, yielding an overall contribution of order unity. As a result, the full expression converges as corsivo Majuscula o aperta tonda phi alla, meno n termina apis chusa tonda, with n majore d0. Numerical consistency and parameter tuning. A direct numerical iteration performed with the reference values leads to convergence towards zero. This behavior indicates that, in the absence of tuning, the system is overdamped. Within the TOE framework, however, the constants are not arbitrary, but are golden tuned. For instance, choosing
Maiuscola C pedice maiuscola gamma uguale a φ alla settimo meno 1.
or equivalently adjusting the asymptotic energy scale as the fixed point condition at phi is satisfied exactly. Fixed point stability. The governing equation can be written in fixed point form, where F denotes the full seventh root operator. Local convergence follows if, which ensures that phi is an attractive fixed point. With the golden-tuned constants naturally emerging from the TOE structure, most notably those associated with the modular and holographic values 1729 and 4096. The nested exponential and oscillatory factors effectively scale as phi alla, meno k termina apis, precisely compensating the polynomial growth of the geometric sector. Result: under golden scaling and appropriate parameter tuning, the seventh root equation converges robustly to the stable fixed point phi pedis maiuscula g maiuscula n quasi uguale a 1.618665, confirming the golden convergence of the RGNU formulation and the role of the Nardelli Gemma golden constant as the unique attractor of the system. Key concepts and components. Quantum spacetime granularity views spacetime as fundamentally discrete at small scales, emerging into continuity at larger scales, with energy eigenvalues related to Mach theta functions. Golden ratio and attractors. Identifies the golden ratio, phi quasi-uguale a 1.618, as a critical, stable fixed point in gravitational dynamics, representing the universe's ultimate harmonic state. Black hole thermodynamics integrates Hawking radiation with Nardelli's theory, suggesting black hole evaporation dynamics naturally converge to this golden fixed point, exhibiting second-order phase transitions. Bosonic photonic CTCs utilizes closed time-like curves, wormholes, and entanglement to unify gravity, quantum evolution, and information, explaining phenomena like cosmic acceleration. Renormalization moves beyond traditional QFT renormalization by incorporating geometric structures and information, providing a unified framework for fundamental forces and constants. In essence, it's a theoretical structure aiming to describe the universe's fundamental workings by finding deep mathematical connections between seemingly disparate areas of physics, like black holes, quantum gravity, and number theory, through the lens of golden ratios and specific mathematical functions. The Nardelli-Hawking renormalization is a theoretical physics framework introduced in early 2026 by independent researcher Michel Nardelli. It integrates black hole thermodynamics into the Nardelli seventh root master equation, a candidate theory of everything TOE that links number theory with quantum vacuum dynamics. Core conceptual framework. The framework's central thesis is that the universe operates as a self-correcting holographic information processor. Key features include temporal substitution. The framework replaces standard chronological time, T, with Hawking evaporation time, T pedis EVA, P, shifting the perspective of the universe from linear progression to a thermodynamic frequency. The primordial singularity as a CTC. It models the initial state of the universe as a bosonic photonic closed time-like curve, CTC. This allows for a cosmic bootstrapping, where information from the future, the stable state, informs and stabilizes the past. Vacuum respiratory frequency. The vacuum is described as having an intrinsic respiratory frequency of 13, functioning as a stable, self-oscillating system. Mathematical anchors. The framework derives fundamental physical constants from pure mathematical symmetries. 1728 modular symmetry, linked to the Ramanujan taxicab number 1729-1, representing a critical threshold where physical reality stops just short of a pure mathematical ideal. 4096 holographic constant, derived through a quadratic scaling process aperta tanda 1728 fratto 27 chusa tanda al quadrado igual of 4096. It serves as a limit for information density in the vacuum. The golden ratio attractor, phi pedis maiuscula g maiuscula, and the framework posits that gravitational decay and quantum information retrieval converge toward a renormalized golden ratio, approximately 1.618, which acts as the ultimate stabilizer of the cosmos. Applications and predictions. Cosmological constant proposes a holographic cancellation mechanism to resolve the discrepancy between quantum field theory and observed vacuum energy. Quantum unitary suggests that the monster symmetry from the monster group acts as an arithmetic guardian, ensuring information is preserved during black hole evolution. Cosmic stability argues that the stability of 10-dimensional supergravity is rooted in modular invariance and the harmonic distribution of primes. This work is primarily hosted on academia.edu and ResearchGate. As of 2026, it remains a highly specialized and theoretical integration of string theory, number theory, and general relativity.